today at J1, modeling functions. Owen, you want to read the I can statements for us?
I can distinguish between situations that can be modeled as linear, exponential, and quadratic functions. I can make graphs to model linear, exponential, and quadratic functions. I can make tables to model linear, exponential, and quadratic functions. I can write equations to model linear, exponential, and quadratic functions. I can compare properties of functions, each represented in a different way.
So when I take a look at the first ones, and they are linear. This is our slope-intercept. This is standard form. When I look at slope-intercept, tell me, Ryan, what's some information that this slope-intercept equation tells us?
The y-intercept.
Okay, our start point is our y-intercept, which would be what? E. So we always think of that as our 0b, that's our starting point, that's our y-intercept. Another piece of information, Joey, from this equation, y equals mx plus b. Slope. The slope. So m is our slope, and slope tells us usually our rise over run. And remember, that's kind of where we did positive slope, negative slope, right? Undefined, and then our zero slope. So when we were thinking about that with that slope guy there, we would kind of think of all those things, like where's our zero, where's our undefined, what kind of line, okay? We just finished spending a month and a half, because of all of our breaks and whatnot, on quadratic. So when we take a look at quadratic model, and I look at this first equation, what is it telling us when I look at quadratic? That first equation. Tells us, what form is that? Gives us what? Something special. Can you help him, Dad? You don't know what form this is, the first one, Joey.
Vertex form?
It is vertex form. And when we are looking at this form, my vertex, Samantha, is going to be what? Actually, if it's a minus here, we're going to say the opposite of h, and then it's going to be k, right? So a lot of times you might see it written as minus h, comma k. So we have spent almost a month doing this. Standard form, both of these really easily can give me my y-intercept, and then we also had our other form in this equation. We had that factored form, where you had x minus a, maybe, times x, and this could be plus or minus, and then plus or minus, like the b, and where you'd solve it, right? So those were kind of our three forms when we looked at quadratic that we've been working with, okay? In absolute value, when we take a look at absolute value, kind of tells us something special like the quadratic. It tells us, when you look at that form of the equation, one of the first things it tells us is we can tell where our vertex is. And the vertex is the same as it is with quadratic. It is the opposite of h, so minus h, k. That's where our vertex of our absolute value function is going to be. And exponential is kind of like linear in what it tells us. So if you're writing these down, so when you do in your homework, you kind of have these things. So when I'm talking about this one being in exponential, I want to be able to identify the y-intercept, again, just like in linear. And my y-intercept will be at that point 0, and it will be whatever a happens to be. Because you're going to be asked to write equations. And the main two that you'll write equations for will be exponential and linear. And I'll give you a graph, or I'll give you a table, and I'll say, okay, what do you know? So when x is 0, that's your y-intercept in exponential. It's also your y-intercept in linear. It is your y-intercept in quadratic, but it's not necessarily the vertex, so you just got to be careful for that, because sometimes people mistake that. And the other thing it is telling us is it tells us if the value of b, if it's greater than 1, we're going to have growth. And notice you are multiplying all the time for exponential. And if b happens to be between 1 and 0, meaning it's a fraction, that's when you have decay. So this graph up here, this is growth. if I was gonna do a decay function, it would have came down kind of like this. And it never really hits that x-axis, but it gets really, really close to it, okay? So those are the 4 different types of equations. And I want you to add up here in your notes because it did not say to add absolute value, but we actually are gonna look at all 4 of these, not just the 3. Notice this is section 9.7 in your book. So if you actually go to take that chapter 9 practice test for Pearson, 9.7 and 9.8 are what we put in this last unit. The reason we felt as teachers is that they didn't necessarily all go with quadratic, and it's kind of more than quadratic, so that's why we stopped at 9.6 for what this test is on. So right now what I want you to do, I want you to look at the 5 graphs and write down from the 4 different types up above, linear, exponential, quadratic, or absolute value, put down right below each one what it is. All right, so our first one, definite, linear. All right, second one, quadratic or exponential? Exponential. So someone said, oh, but I couldn't see. But if you're looking at that and it kind of is curving up, this next one is definitely quadratic. And as we look at the bottom 2, we should have absolute value and another exponential, and it's decay. Now, in your homework, for some of them, I'll just ask you to identify this, and then for some of them, I'll ask you to give me the equation. Could we very easily give the equation for this linear? Please try and write that equation and check with your shoulder partner, right? What would be our slope? What would be our y-intercept for this linear equation? You should be able to do that, okay? Becca, what would be my y-intercept?
Negative 1.
-1. So I could have plus a -1, I could just have -1, right? Owen, what am I having for my slope? 2. So y equals 2x minus 1. So it's should be very easy to write a linear equation if you are given a table or a graph. The exponential, sometimes a little harder, but these ones both went below the x-axis. Most of yours will not. And absolute value, we should be able to at least tell the vertex to get it in that form of the equation. Same with our quadratic. So, on the top of the next page of your notes, it says we're choosing a model for our tables. Tanya, would you read what it says below that first table?
The y values have a common difference of 3. Linear model fits the data.
So, if we are looking at a table, the key thing I want you to always think about in all of our tables is anytime you're trying to choose, we are looking at the change in y, that's that triangle. Delta y means change in y divided by change in x, okay? I notice that all my x's in all 3 of our tables change by adding 1. Some start at negative, some might start at a positive, but my x is always changing by 1. And so if I notice there is a constant difference, meaning you are adding or subtracting the same number, right? That's a definite linear equation. Anytime I notice that. I start looking at this one and I'm going, okay, this is 0.25, but then it's 0.5 if I'm adding, and then it's 1. So I can't add the same thing. So then I just want to start thinking common ratio. And common ratio means we are multiplying. So, and in this case, if you look at it, we are actually multiplying everything by 2. So if I am looking at multiplying by 2, that common ratio, then it's going to be an exponential. And when we write that exponential function, if I'm looking at this one, as I look at both of these, can I try and write an equation for both of them? In the first one, what do I know auto is my y-intercept? 5. So I know back here I have a plus 5 and I have x. Can I tell my rate of change if I am looking at it, Ryan?
Yeah.
It was
+3.
+3. So this would be my equation for this table, right? So there's some questions in your homework that are just going to ask you to identify if it's linear or exponential. Usually your linear ones, they might also ask you to write an equation. Exponential. How do we start exponential? Y equals, it is always our y-intercept. What's our y-intercept? 0, 1. What are we multiplying by? We're multiplying by 2. to what power? That's my exponential. Exponential has an exponent, right, in that equation. So if you don't have an exponent, you can't use exponential. And then the last table here, again, I want you to think about change in y over change in x. And my x is always changing by 1, but I start looking at this, and if you tried to multiply, you can go, yep, I can't multiply, right? So then you look at the numbers in your table and you go, okay, I'm going to add. What do I get from 1 to get to -2? Well, I have to subtract 2. Then I have to add 2. Then I have to add 3. And we might notice that what is happening is it's symmetric around this 0, -1, right? So it's kind of telling us, so in your homework or on the test for unit I might give you a table like this and say, what's the minimum? Is it a minimum or maximum? What can you tell? Well, at this point, this 0, -1, that's definitely my minimum, right? If I was thinking of graphing this, I know that at 0, -1, I kind of have a parabola, right? Which means if I can't see the first difference, you're going to look at what's called our second difference. That second difference, all the second difference is that I noticed that this first one didn't have anything in common. The second difference, it's the same number every time. So it says for quadratic functions, you have a second difference that is constant, meaning you're adding the same thing usually. This is going to give us a table that models quadratic. Okay? So if we can look at this, we also notice that we have a minimum, right? So I even know my vertex in this one. My vertex is at 0, 1. Okay? I probably won't have you write equations for quadratics unless I give you enough information. What I want you to do for each of these, determine if it is linear or exponential or by looking at those tables like we just did, look it up above, and think, is there a common first difference? Do I multiply by something? If I don't have a multiplication or a common difference, do I have a second difference? Okay, so it's going to be one of the 3 forms. It's not going to be absolute value, so go. Check with your shoulder partner and see if you agree. Maria, what do you guys have for the first one? Exponential. Definitely a multiplying by. What does it look like we're multiplying by? 3, right? Okay, next one, what did you have, Tanya? Should have linear if we are looking. If I look at that next one, should be quadratic. What did you guys have for the first difference? 96 to 150. Someone want to tell me what I added there? Did anyone figure those? So, take your calculator right now. 150 minus 96 gives us what for the first one? How much? What did you say? 54. Okay, I thought you said 44. Thank you. The next one. Not the same, right? Common difference. 216 minus 150 gives us 216 to 294 could give us. So all of a sudden I'm looking at it, and I couldn't multiply by something to keep going bigger. And so now I look at the second difference. 54 to 66. 66 minus 54 gives us. Should have how much? 12. Right? 66 to 78. 12. And so this is helping me decide that it is quadratic, that second difference. Because I definitely could tell that this wasn't a multiply, right? So when you look at those, that's what you kind of got to be thinking about. Now this one, as we are looking, it looks like it is definitely linear. And our last one looks like exponential. Okay? For the linear ones, I want you to write the equation. For the linear and for the first exponential, I want you to write the equation. What did we have for our common difference in this first linear one? What did we end up with going from negative 15 to negative 23, negative 23 to negative 31? What were we looking at, Becca? What was happening? We were subtracting what? we're subtracting 8. So in my equation, what does that look like? Y equals, yep, and we're going to put negative 8x. I need my y-intercept. What am I looking at for my y-intercept? Negative 7. So instead of subtracting 8, I'm going to add 8 on to negative 15, and I get at 0 that it's negative 7. So I have to find that 0 point. If I'm looking at this first quadratic, in the first quadratic, Devin, can I tell my y-intercept? Y-intercept is when x equals 0. What do you have? In the first table, when x equals 0. Yeah, just the first one. The third one is yucky, or not as nice. So negative 3. Joey, what am I multiplying by each time? 3. So I have negative 3, and then I'm going to put times 3, and this would be to the x power. So that's how we write our, if we are looking at it being an exponential one. Find your y-intercept, find the common multiple. Similar to slope, you find the common difference, that's your slope. What did you add or subtract each time? Find the 0, what is your y-intercept, okay? We have other ways of finding those than going back like we did. So what I want you to do now is it asks you, and we just have to add one thing. So tell me if it's linear, exponential, quadratic, and I want you to add or absolute value. So it could be absolute value also. So if I'm going down this first column, the first one going down, y equals 2.5x plus 7, Owen should be linear. Ryan, the next one. Exponential. I have that x as an exponent. That is the key thing for exponential, right? The next one as I look at, I should have, right? Quadratic. You have an x squared. Could I rewrite this so that it had y equals x squared minus 15? That is a nice, easy one to tell the vertex, right? The vertex of this is at 0, negative 15, and my parabola goes up, right? This vertex is at 0, negative 15. If you were going to draw me a picture, Samantha, of that exponential one, what would it be looking like?
The y-intercept would be at 4.
The y-intercept is at 4, nice. Please put these pictures by yours, and what else do you know? Is it going up or going down? Going up. So something like that. If we were looking at the linear one and I asked you to draw a rough sketch of it, again, we kind of know that our y-intercept is up here at 0, 7, and it's going to be going up to the right. So as you do each of these, if there's kind of like a key feature that you can tell me, I want you to tell me that. And I would like you to now do the rest of them with putting linear, exponential, quadratic, or absolute value, and draw a little picture next to it, just a rough sketch of what it looks like if you were going to do that, okay? All right, Tanya, let's start out. Y equals absolute value of x. Definitely absolute value. What does my graph look like? Vertex at 0, 0. And I got that V shape, right? Next one, if I am looking at Devin. Linear. What's a key feature that you know about it being linear? I'll get you next. We might rewrite it, right, in slope intercept form. Y equals, we have what? Negative x plus 5, which tells me my y-intercept is where? At 5. So I know 0, 5. And the other thing I know is that my graph is going to go down. Joe, you ready for the next one? Okay.
It's quadratic.
It is quadratic.
And the y-intercept is 0, 8.
Y-intercept is 0, 8. And what else is that 0, 8? Besides the
Vertex.
y-intercept. It's also my vertex. So would this equation have any solutions? Would this equation have any solutions? No. So for unit I, this had no solutions, right? This is above my x, doesn't have any roots on my x-axis, right? It doesn't ever cross it. This has no solution. All right, Otto, what do you have for this one? Exponential. Key features.
Y-intercept is 2.
Y-intercept 2. Curve up, curve down. Is it growing when I multiply? No. It's actually getting quite a bit smaller, right? And taking a fourth of each number each time. And if I plugged in 0, remember, anything to the 0 power is 1. That's why when you plug in 0 for x, it gives us 2. All right. Who haven't we hit over here? Owen, next one.
Absolute.
Absolute value.
And y-intercept -5.
Okay, so actually we don't know that that's necessarily, well, it is going to be our y-intercept at -5. What else do we know about it? Besides that y-intercept being at -5. It is going down, so it is going to go down. So this is going to be an absolute value going down, and I know that this isn't going to be exactly my vertex of -3, -5 when we are looking at that, because you have that 2 in there, but it will definitely give me the vertex of 0, -5. This -2 affects the vertex a little, so we're not going to worry about those. I want to ask you, how about that next one, Samantha? What do you think?
I said linear.
It's up linear. I agree, because this is like a 1 in front of x. So this could be rewritten as y equals 1/7 x. So definitely linear. And if I was going to draw the graph, it goes through 0, 0, right? And is it steep or flat? 1/7. Not steep. Very, very flat. So, on the test for this unit, on unit I give you the same type of things with quadratics. And remember, if you have a fraction like 1/7 or any fraction, the smaller it is closer to 0, the wider it is, right? So this is a flat graph in linear. When we do quadratics, that makes it flat. Whereas if I have y equals 2.5x, that's going to make it a much steeper graph. All right, Tanya, you ready? Quadratic. Can you tell me the vertex? 3 and 5. And Becca, would this go up or down? This would be going up. So a vertex of 3, 5, it would be going up. Would we have a solution? There would be no solution to this one, right? If I plugged in the b squared minus 4ac, the discriminant, it would come out to be negative. Next one should be linear. What kind of a line is it if it is linear at 13.5? Horizontal, right? Y equals 13.5 would be a horizontal line. And this last one actually is linear also. I don't know if you remember, that's when we did point slope form. That was the other form of equations that we didn't have up there for linear, but this was your point and slope. So you have your slope here, and it goes through a point, 3, -4, okay? So the last part that you're going to be asked to do is to make a graph. So it's questions 6 to 20, there's 14 questions. This one says, what type of model what type of function best models this data? So first plot it, and I also want you behind each of these to tell me if it's not a constant multiplier, tell me the constant difference, okay? So we're going to plot the points. So we are looking at our graph as we are looking at this. We're going to plot 0, 18, 254, right? Then I'm going to have a point where at 1, it's a little further up, 17, 19. This is still below the 20,000, right? 19,695. Do we have any idea what year 0 means for the company, what year that actually was?
The start of their business.
It's the start of their business. But do we know what year they started their business? No. It's just that this is the year that they started out their business. So when we start looking at those common differences, anyone have the first one for me? That you calculate, because they're not the same. So that's why I want you to put them in your calculator. First one, what do we have? Tanya? 476. How about the next one? Brian, what'd you get?
45.
45. Next one, what do I have? Right?
480.
480. And last one, we have another 480. So, which one? Linear, quadratic, absolute value, or exponential? Looks like constant what? Looks like a straight line, right? Looks like linear. When you have a real world problem, is it going to be exact? No, that's why it says what is the best model. It's not going to be the exact model. Because when you're working with real data, it doesn't come out to fit exactly, but it is really close to linear. And then it says we'll write an equation. So what could you estimate this slope to be? Well, we went from 476 to 485 and we had 2 at 480. I'd say y equals 480x. That's a pretty good slope, right? That's kind of my average of those. Plus, what's our y-intercept? 18,254. What I want you to write down is what does the y-intercept in this situation, what does it mean? And what does the slope in this situation, what does it mean for that slope of 480 and that? So, please talk to me.
It means how much money they set it up with.
The money, or the, in this case, our income, right? How much we had in our account, our money we started with. Year 0. We do not know like what calendar year 0 is. It's the first year, like before we started that company, we had $18,000 that we set aside that was ours for the company, right? What does our slope mean? Raise your hand. Someone check.
How much money they make in a year?
So this is the money, and in this case, we're going to say our $480, right, per year. That's what we're going up by. So if on the final you're asked to explain what those slope and y-intercept mean, kind of thinking about what they mean in the context of that situation. I'm going to hand out graph paper. You need graph paper to do 6 to 11. It says graph them, then find the model that's most appropriate, just tell that. When you do 12 to 14, you are looking at the functions and you are simply telling which one models it best again. And then in 15 to 17, that's where you have to write the equation. Now, if it's exponential or if it is linear, you should easily be able to do that. If you get to quadratic, they might be a little trickier. And you're doing through question number 20. So just to make sure you have that.